All right, there we go. Welcome everyone to the Iowa Microsoft Azure User Group. As we always talk through, we've got a lot of resources that are available. You know, obviously we use Meetup to pretty much promote and schedule all of these events. We also have a Slack channel that you can chat with us. We have YouTube where we post all of the recordings that we put together on these sessions. And then there's myself, Derek, Alec, and Corey, who are the organizers. So if you think of anything that you want to present down the road, feel free to reach out to us. Right now, we're looking for some topics and presenters. So if you have some ideas, either for topics or something you really want to present on around Azure, please reach out to one of us and let us know. Today's session is going to be on Azure Synapse, presented by Justin and Eric from Xeris. And then on the 8th, we're going to be doing a session on Azure Sentinel. And I know Derek's still finalizing the speaker for that. But as you can see, for March 23rd, we're still looking for some ideas. We've got a couple in the works that we're trying to figure out. But as I said, if you have some that you want to bring to the table, please do. And here's some other learning resources that are available to you. And if you need any of these links, just reach out and let us know. But we'll go ahead and get started. But for today, we've got our Platinum partner sponsor as Source Allies, and Bronze as Lozanetek, and we're going to be leveraging those relationships to put out our prizes at the end of this event. We're going to be doing 2 AWS gift cards to 2 lucky winners. With that, I'm going to go ahead and hand it over to Justin and Eric to get started on the Azure Synapse.
Thanks, Bruce. All right. Everybody see the presentation okay?
Yep.
Okay. Well, hello, and welcome, and thanks for joining us today for an introduction to Azure Synapse Analytics. As Bruce said, my name is Justin Moen, and I'm the Director of Data Engineering at Xeris here in West Des Moines, and I'm joined by my colleague, Eric Kleider, who's a data engineer here with us at Xeris as well. So today we're going to provide you with an introduction to Synapse and what it is, how to plan for a successful implementation, and how to effectively execute on that implementation by utilizing the Azure Data Lake Gen2, pipelines and data flows, SQL Pools, and other components that are within the Synapse tool set. As many companies have discovered, data projects are hard. Data projects can be overwhelming, especially as to where to start and how to start. According to a study by Accenture, only 32% are able to realize tangible and measurable value from their data. And only 27% say that their data and analytics projects produce insights that are highly actionable. So with such a push to become data-driven, why are the results of these efforts so discouraging? You can't overlook the importance of a proper data foundation when you embark on an analytics journey. We've talked to many organizations who want to know more about machine learning, artificial intelligence, and advanced analytics. But when we get down to defining how to start those projects, their current data infrastructure and processes are causing enough havoc when just trying to do basic reporting is tough. A proper data environment will set you up to do the basics well and will open the doors to advance into more complex analytics when the time is right. So what are the components that go into the proper data foundation? So here's a prediction from 2019, and even though we're in 2022, the components mentioned still ring true to setting up that solid foundation. It's important to know that not all data is equal. It isn't all used for the same purposes, and the users who need it varies as well. Also, the format that it's in and the frequency that it gets used varies greatly as well. We like to say by placing your data use cases in the appropriate quadrant helps you understand the data requirements to achieve it. So first we have to understand that the data that we're using is known or unknown. And known means purposed, structured, and defined data. Unknown means semi or unstructured data. Then we need to understand the questions we wish to ask of the data. Are they known or are they unknown? Known means well-defined and specific with ways to measure success or failure. Unknown questions are more exploratory in nature or hunches you may have or be curious about. Historically, relational data stores could only really store known data well, and you could use it to report off of well-defined known questions. That's where, with the incorporation of a data lake, we see organizations able to support 30% more use cases. We can now store data. We can now store data before it's fit into a defined schema, and we can explore it even if we really don't have well-defined questions yet. This is where your current or future data scientists will want to be able to explore as well. So now you've heard a little bit about the data quadrants. Let's talk about why we are all here today, and that's to learn a little bit about Synapse and what Synapse is. Historically, hybrid has meant lots of different tools, potentially across multiple data platforms and vendors. Even until recently, even those who standardized on Azure Cloud would have to use a lot of different products to achieve both relational data stores for reliable reporting and a data lake for flexible storage, exploration, and big data analytics. That's what's made Synapse unique. This one platform incorporates both relational and unstructured data storage, tooling for the modern and complex ETL, direct integrations for reporting and analytics, all with low to no code interfaces and query and syntax that users are already familiar with. Synapse brings the hybrid approach of a data lake plus data warehousing all into one place, which makes it very easy to manage and adopt within your organization. When working with Synapse, users will access the Azure Synapse Studio from within the Azure environment. As we just got done mentioning, this is where before within the Azure environment, you had to access many different tools. Synapse Analytics Studio makes it easy to access in one spot. So Synapse Analytics Studio is a unified environment for data integration, data management, monitoring, and security, all in one spot. It can connect to many different data sources, whether it be in the cloud or on-prem. We'll talk a little bit more in the presentation of how to connect to these data sources. To expand a little bit on this, you can see from the bottom that we've got the Data Lake Gen2, and this is where we store our data. This can be stored in many different formats, such as a CSV file or a Parquet file, just to name a few. But storing data in the lake is cost effective, being that it's in blob storage. Next, we have the data integration component, which is composed of the Synapse Pipelines, which were used for orchestrating our data and copying data from source to a target and other data orchestration opportunities. The Manage Hub component is used to manage data connections, schedule and trigger the pipelines to run, monitor resource usage, and set security in one location. Next, we have the SQL Pools, and there's two types of these, serverless and dedicated SQL Pools. And Eric will define what those are a little bit later in this presentation. The next part is the notebooks in the Apache Spark Pools, and these support multiple programming languages such as T-SQL, K-SQL, Python, Scala, Spark, SQL, and .NET. These are all tools that many of us are familiar with, and a lot of times many people have a preference to use one or the other. Apache Spark notebooks allow you to use the environment or the database language, programming language that you're more familiar with and more comfortable with. In addition to the other components that we've talked about within the Azure Synapse tool and then Studio, there are other tools that are tightly integrated, such as Azure Machine Learning, Power BI, and a new tool recently introduced called Azure Purview. And Azure Purview is a unified data governance solution that helps manage and metadata from across many sources, and it can help identify and monitor your sensitive data and understand your data lineage from where the data is coming from. This is, like I said, this is a new tool that just became generally available on September 28th of 2021. So now we've got to figure out, after we've identified that we want to use Synapse, how do we start? So there's two angles to think about how to start a project like this, the conceptual strategy and the tactical execution. Both are extremely important, and we're going to try to, in our very limited time today, to give some helpful tips on how to get started with both. We all want you to leave today with a solid understanding of what a Synapse is and how it lays a great data foundation for businesses who are trying to prepare themselves for analytics. We also want you to feel like you have an understanding of how to practically get started, see our processes for doing the necessary preparation for success, as well as understanding the tactical and technical components that go into setting up the environment and starting to bring data into it. And this is our specialty, and this is what we do. Data is always a moving target, and it always will be. You're never going to get to a place with any data environment where you can step back and say, this project's done. There's always more data to bring. There's always more analytics to look at and to build. That's why we specialize in working with your team to set up the strategy that gets you results fast. It's amazing how quickly the execution piece, which is step 5, can come together if you really work through steps 1 and 4 well. And we have processes to make this environment successful. Typically, the first project to lay the foundation for any analytics environment can take anywhere from 12 to 14 weeks to complete. And based on some feedback from customers, this is typically much faster than customers say they can do it if they were working on their own. But once we get into step 5, how do we actually start working with Synapse? Once again, it's much less overwhelming if you have a clear target at what you're shooting at. But let's take a look at how the tool is set up and some of the key pieces you need within your environment. To get started on the tactical design, we typically define our data into 5 different zones. Each zone is decoupled from the previous zone, and by doing this, can help prevent your data lake from becoming the dreaded data swamp. The first zone is the data sources, and this is really any source that contains data that may be useful now or potentially later. So if you've got data and sitting in a SQL server or an Oracle database, an Excel spreadsheet, Salesforce, any sort of data source, this is where these would be identified. The next layer is the raw zone. And you can see from the picture, this contains copies of the data from the data sources. The data in here should be direct copies of the data and from the data sources, and in most cases, not contain any changes or transformations. The next step is the transformation zone. This is where we begin to alter our data from the original structure, performing actions on it, such as replacing null strings with spaces and null numeric values with zeros, adding derived columns, or renaming columns to a common naming convention, and potentially other actions here as well. And note, unless it's needed for business logic, we typically at this stage do not combine data from multiple data sources in this zone. The fourth zone we call the curated zone. With data from our data sources now in a more standardized format, this is a zone where we can start to join and combine data from multiple data sources. As you can see from the raw zone, the transformation zone, and the curated zone, those are all maintained within the data lake. The last zone that we're going to reference here is the relational data store. And like I said, this is now stored in a SQL database, and what used to be called the SQL Data Warehouse is now called a dedicated SQL pool within Synapse. And this is where we move our data from the curated zone into the relational data store. And in this relational data store, this is the pool where tools such as reporting platforms such as Power BI, and you might grant access to some end users for reporting purposes. This is where they'll connect to start doing their analysis, as it's an environment that's optimized for reporting. With the different zones, our data is now organized as each zone serves a purpose, whether you have users that want to report from the relational data store in the SQL pool, or have data scientists who are curious as to the data that is available and could potentially be the next source for the next big discovery for your business. Now I'm going to turn it over to Eric, who's going to take you through what the data lake looks like in Azure Synapse and other Azure Synapse components. Eric, take it away.
Thank you, Justin. So Justin hit on a lot of the whys. Why are we using Synapse? Why are we doing this? Why are we doing that? So I'm going to take you through more of the hows. How do we actually get data into the lake? How do we move it around? And how do we do transformations? And the first step you might be curious to know is, We talked about those raw, transform, and curated zones of your data lake. Well, what does that actually look like? So what that actually is we have the Azure Data Lake Storage Gen 2, which is where you're going to be storing all of your data. This has a hierarchical namespace that allows you to easily sort out your data. So each of those zones is going to be a different folder inside of that data lake. And then further subdivisions allow you to quickly and easily find files that you might be looking for. For example, on your screen here, you'll see a screenshot. The details, we have the raw zone, and then which source we're pulling from, obfuscated for your view, which data model object it's going towards, the year, and the month. This allows us to very easily find data that we're looking for, whether that's manually or dynamically through programming. The other benefits of the Azure, can you go back a slide, please, Justin? The other benefits of Gen 2 are just, again, how easy it is to find your data. And then for any of you who are curious of why we're using Gen 2 storage instead of Gen 1 storage, Gen 2 is a straight upgrade onto Gen 1, and Gen 1 will be being shut down in early 2024. So there's no reason to ever pick Gen 1. That's just a pro tip for you guys. And then the next thing we need to worry about after we've gotten our data, we know where it's going to end up living in the data lake, is how can you go to the next slide, securely connect to our sources. For that, we're going to be using a tool called Azure Key Vault. This is a tool that's not directly inside of the Azure Synapse environment, but is highly integrated and very easy to use inside of the Azure Synapse environment, which is a common theme you'll see throughout tools that are used in conjunction with Azure Synapse, is that if they're not a direct part of the environment, they're usually highly integrated and very easy to use. What this tool does is it handles credential storage for any of your anything that you're going to be accessing through Azure Synapse. So for example, if you have a SQL server that you have to give some username and password for, you can store those credentials inside of Key Vault. And you can see how tightly integrated that is through the image on the right side of the screen there. At each step, we have the option to input whether we want raw credentials or whether we want to put an Azure Key Vault for those connections. And we can do that at different levels, whether it's a connection string level or just a password level. So to kind of summarize where we're at right now, we've talked about where our data is going to be living, what that looks like, and how we're going to be storing access and credentials to that data. Next up, we're going to be talking about how we connect to those data sources themselves, not just how do we store the credentials. For the connections to data sources, we have three main tools that we're going to be using, which are link services, integration runtimes, and datasets. Link services are essentially connection strings. If you've ever worked with connecting to SQL databases or any other sort of connections, that's probably the best way to think about what they are and what they do, is these are storing all the connection information and allow for quick testing of your connections. On screen, you'll see various different out-of-the-box connectors that are just Azure tools, and there's also many, many more that aren't listed here. In fact, there's 90 out-of-the-box connections, or more than 90 out-of-the-box connections that work with a wide variety of sources. Once you've set up your link service, you're going to have your integration runtime. This is where the actual compute is happening. So this is where anything like a pipeline, which I'll talk about in a little bit, or any sort of activity is going to be run. They're all going to be going through integration runtimes, which is, again, where compute happens. There's two types of integration runtimes that you can use for your environment. The first being a self-hosted and the second being Azure cloud hosted. For self-hosted runtimes, you're constrained by only having the resources that you have in your on-prem environment. However, you do have better access to lock down any access that integration runtime has, and you don't have to let any cloud runtimes into your network. You can do everything through the integration runtime and then go to the cloud from that one access point. Cloud hosted, however, allows you for much easier scalability. So you can scale up and scale down if you need to. Let's say you have super large amounts of data and for one of these queries, you can scale up, make that quickly happen, and then scale back down to a more manageable cost. And this is a pay-as-you-go model, whereas self-hosted, you're taking all of the costs by hosting the machines yourselves. And then lastly, for this kind of connection step, are datasets. Datasets are kind of a complicated beast if you haven't been working with Synapse, but essentially the way to think about datasets are abstract representations of your data. So that can be pointing to a file, it can point to a table in a database, or it can point to a folder full of CSV files and be accessing all of those files at once. The reason that we aren't that we use Datasets is that this is how Synapse interacts with your data. It doesn't actually talk to your data, it talks to Datasets. So the way that looks is we'll load the data set into memory, do all the transformations there, and then at the end of the activity, when you're going to sync your data wherever it's going to end up, that's going to be the actual changes that are applied there. So far we've covered where our data lives, what it looks like, and how we're connecting to our services. Next part is the meat and potatoes of what actually happens inside of Synapse, which is the pipelines. This is going to be how everything happens, all the data orchestration occurs inside of Synapse. You're going to be moving data around from lakes, from sources to lake, and eventually from the lake to the relational data store. But what actually are pipelines? Well, pipelines are just groups of activities, and these activities can be anything from looking up tables to actually performing complex ETL processes like loading data in, cleaning it up, and then processing it to move it forward to the relational data store or a farther zone in the lake. So to give an example of what these kind of look like, we can see a pipeline with 3 activities. If you can go to the next slide, please. We have a lookup activity that's just going to be listing out tables. Then we have a for each activity that's going to be looping through those tables and copying them into our data lake. So this is ingesting things from the source into the raw zone of the data lake. And then finally, we have another activity that's going to trigger another pipeline that's going to be doing all of the data transformations on those sources we just pulled in. I know some of you might be questioning, well, why don't I just have those activities for the data transformation inside of this pipeline and save that step? The reason we're doing that is there's an inherent 40 activity limit in pipelines. So you want to make sure that you're separating things into logical units and not getting into the case where you run into that 40 activity limit and have to kind of splice together activities that may or may not be related. So we kind of split it off into ingesting things into raw, moving them from raw to transform, and keep everything logically consistent so you can find what you're looking for easier. Additionally, some of the eagle-eyed viewers out there might notice a blue box in the upper left that says Publish All. I want to highlight this to you guys. If you ever start implementing the tool, this will be an important thing to keep out for. Azure does have Git integration to save your work and keep your progress that way. If you, however, don't choose to do Git integration, when you're working on your pipelines or working on your data flows, you'll when you're working on your pipelines and data flows, you'll only be able to save your work when all at once. So if you work on multiple pipelines, you have to save them all at once, and you're only able to save them if they are valid and can compile. So there's no errors in there, it's like forgetting to include certain variables or parameters. So that's just a fair warning to you guys to make sure to save often and only work on 1 or 2 things at a time so that you're not ending up losing some work on a Friday afternoon when you just want to get home. Now, next from pipelines, we'll talk about the most important activities there are out there, which are going to be your data transformation activities. The 2 big ones are going to be data flows and notebooks. Data flows are a highly visual data transformation tool that has a no-code, low-code interface similar to the pipeline we just saw. These are mainly used for data cleanup and data movement and other routine activities. Let's say we're ingesting data every day and then we're transforming it and moving it on the pipeline. That's going to happen every night. So we're going to set up a data flow for that. Whereas notebooks are more for one-off activities or more for things that involve a deep need for customization, and notebooks are the code-based alternative to data flows. So if you've ever heard of Jupyter notebooks or any other sort of coding notebook, that's essentially what happens here, is you can run them. And the main use for these are one-off visualizations and explorations, or machine learning applications where you need to have a little bit more depth to your transformations. Now, I would be pretty evil if I said how visual data flows were and then didn't give you an example of what one of those looked like. So on screen now, we can see an example of a data flow who's taking in multiple different sources, joining them together, cleaning up the data, and then syncing it into a different zone in our data lake. The main benefits of the visual nature of the data flow is how easy it makes it to recreate what could be otherwise complex SQL statements. If you have any baseline knowledge of how to read a SQL statement, you can pretty easily translate that into a data flow and print that here. So you can see we have selects, we have joins, we have adding calculated columns, and we have essentially saving the table at the very end. Additionally, you'll notice at the bottom of your screen, you're able to pass in parameters to your data flow from your pipeline. There's lots of different benefits for that, but one use case for that is like what we're doing here, where we're taking the current time from the pipeline and passing that into all of our data flows so that all of our files are created with the same timestamp for when their files are created. That way, if we're looking for a specific batch of files, we can look for just one timestamp as opposed to having to vary it by a few milliseconds or a few minutes, depending on how long that job runs. And I know people might be asking, you say it's really easy to do this. How can I make sure that I'm doing it correctly? Well, at each step in the data flow, we have the ability to do a data preview. So any of those activities, if you go to the next slide, when you click on them, you'll have the option to do data preview. And this shows you a live state of what your data looks like exactly at that moment in time. So if I've only done one of those two joins, I'll see what it looks like after the first join, and I can step through each step and see what my data looks like at any point in time before I commit to that being the final version of the data flow. And additionally, the reason I'm only highlighting the data preview button and not showing you is because I'm sure you guys don't want to look at an entire table of obfuscated data. But additionally, it's because I want to point your attention to that Learn More button there. One of the things I really enjoyed about Azure Synapse working with it for implementation is the fact that documentation is linked readily throughout the tool. So if you click on the Learn More button there, it'll take you directly to documentation for the join activity and teach you how to do that correctly and easily so you can get up and running a little quicker and get moving with easy access to that documentation instead of having to spend time looking for it online. So we've talked mainly about connecting to our data. We've talked about how to move it around. So the next thing I want to talk about is the end goal of where we want our data to end up. And that's going to be inside of SQL Pools. SQL Pools can be thought of essentially as your relational database. And this is where you want your data, your clean data models to end up. There's two different types of SQL Pools you can use. We have serverless SQL Pools, which are essentially mostly used for quickly spinning up or exploring your data in various different formats. So let's say we're looking at a file in our data lake. I want to see what the contents of that file are. We can do a quick right click, select top 100 rows, and quickly look at what the data is, and that will be using a serverless SQL pool. Additionally, this is also for data that doesn't need to live past the query. So we can have one query that creates everything and serves it up there. This is, again, serverless, so you're going to be pay as you go. So you're going to have to pay only for the resources you're using, and then nothing is live after the query is done and shut down. On the other hand, we have dedicated SQL pools. This is where you're able to store your data as well. So you're paying for the storage, and then you can scale your compute based on your needs. It's optimized to reduce storage costs. So essentially, storage is very cheap, and we're going to be mostly paying for compute at this point. If you're familiar at all with SQL Data Warehouse, this is now known as dedicated SQL Pools. And this is where you'll be connecting all of your reporting tools to, and this will be live, essentially 24/7. But you do have the option to turn these off if you don't need them outside of, say, the workday, or you don't need them on the weekends, for example. So now we've kind of talked a little bit about everything going on. We have our data in our final data step. So what are the next steps here? The next steps for that are we have a very good look at our entire data model, and we can pull in enterprise reporting. We can look at machine learning tools, and we can make sure that we can start to get out of that 32% of people we can start to become able to use our data. We can get into the good quadrants Justin was talking about earlier. Do you have any questions? Feel free to speak out loud or throw them in the chat. I know I saw one earlier that I will look into. It looks like it was already answered. So if there's any other questions, feel free to ask them now.
And if you wanted to wait till the end, you can also ask your questions at the end after we've gone through all the presentation material. Are you guys done then?
Yep.
Oh, okay. Sorry. I thought Justin, you had some more content.
Hi. So James was asking,
Go ahead.
James is asking, how can we determine how much it would cost to move our infrastructure to Azure Synapse? It's on a per use basis. We don't know how that's working so far. It's very complicated to determine ahead of time what you're going to be paying for. Usually, one of the recommendations I've seen is to kind of run it for a month and see what the costs are, the expected cost of running it for a month. The important thing to keep in mind, though, is storage in this environment is extremely cheap. So you don't really need to worry too much about storage. It's more about how much computing you're going to be doing. So if you're bringing in large amounts of data, that's not going to be too much of a concern. It's more about how much you're going to be transforming it, moving it around, or how much you're going to be doing with the compute there. And hopefully that answers your question. If not, feel free to ask a bit more.
Let's say real quick, and Microsoft does offer a tool out there that you can, enter in some variables for, how much data you have and whatnot. There's a lot of questions and a lot of variables to be used, and I don't know, if you know the answer to the questions of how much data movement. But to Eric's point, I think kind of the recommended idea is to use it for a month and see how much it is.
Yep. And there's also ways to set caps. So if you only have a limited budget, you can set a limit and it won't allow you to spend more than that amount of money. So you won't have to worry about going over budget as well.
Other questions?
I'll go ahead and stop the recording in case anybody wants to ask off recording.